Hey everyone, welcome back. Today we are going deep on turbo modules, one of the three pillars of React Native's new architecture, alongside Fabric and JSI. If you've ever wondered why your app takes forever to boot when you've got a ton of native dependencies, or why native calls always felt a little laggy, this video is for you. By the end, you'll understand exactly what changed under the hood, why it's faster, and how to actually write one yourself. Let's get into it. So, the old architecture. For years, React Native ran everything through what's called the bridge. JavaScript and native code live in totally separate worlds, different threads, different memory. So, to talk to each other, every single message got serialized into JSON, queued up, batched, and shipped across asynchronously. Every single call. And here's the part that really hurt. All your native modules, camera, storage, whatever, got initialized the moment your app launched, whether you used them in that session or not. On top of that, there was zero compile time type checking. You could pass a string where native expected a number and you wouldn't find out until your app crashed at runtime. This is the exact problem turbo modules were built to solve. The new architecture actually has four moving parts that work together. JSI is the foundation. I'll explain exactly what that means in a second. On top of JSI, you've got turbo modules, which handle native module calls. Fabric handles UI rendering. That's a separate topic, not what we're covering today. And Codegen ties it all together by generating type-safe native bindings from your JS or TypeScript code. Today, we're zooming all the way in on turbo modules specifically, how they replace the old native module system, and why that replacement matters so much for real-world app performance. So what actually is JSI? JSI stands for JavaScript Interface, and it's a lightweight C++ layer that sits right inside the JS engine. Hermes, JavaScript core, whatever you're running. Here's the key idea. Instead of JavaScript sending a message across a bridge and waiting for a response, JSI lets JavaScript hold an actual direct reference to a native C++ object or function. That means calls can happen synchronously, immediately, with zero JSON serialization in between. This one architectural change is what makes everything else, turbo modules, Fabric, possible. JSI isn't a feature you use directly most of the time. It's the plumbing everything else builds on. This is honestly one of the biggest practical wins of turbo modules, lazy loading. In the old system, every single native module you'd registered got instantiated the moment your app launched. Camera module, Bluetooth module, analytics module. Doesn't matter if the user never opens the camera screen in that session, it's already loaded, taking up memory and startup time. Turbo modules flip that completely. A module only gets initialized the first time JavaScript actually reaches out and touches it. So if your app has 30 registered native modules, but a given session only uses 5 of them, only 5 get initialized. Your app startup time now reflects what the user is actually doing, not the total size of your dependency list. For apps with a lot of native modules, this adds up fast. Let's put the two architectures side by side so the contrast is crystal clear. On the left, the old flow. JavaScript sends a message. It gets serialized to JSON, queued on the bridge, sent asynchronously, and eventually reaches your native module, with unavoidable overhead at every step. On the right, the new flow. JavaScript talks straight through JSI using a direct C++ reference, straight into a turbo module that only exists if it's actually been called. Fewer steps, no serialization, no queuing, and no wasted initialization. That's the entire architectural shift in one picture. Everything we've talked about so far, JSI, lazy loading, this diagram is where it all comes together. Now, how do you actually define a turbo module? This is where Codegen comes in. You write a single specification file in TypeScript, or flow if that's your setup. This file describes the shape of your native module, what methods it has, what types they take, and return. At build time, Codegen reads that spec and automatically generates the native interface code for you. Objective C boilerplate for iOS, Java, and C++ boilerplate for Android. You never handwrite that glue code yourself. And because it's generated straight from a typed spec, any mismatch, say you pass a string where native expects a number, gets caught at compile time. That eliminates a whole category of runtime crash that used to be really common in the old native module system. Let's make this concrete with real code. On the left, that's the spec file. Notice the interface extends turbo module, and every method has explicit types. GetItem takes a string, returns a promise of string, setItem takes two strings, and returns void. At the bottom, turbo module registry getEnforcing is what actually pulls in the native implementation by name. On the right, that's just Normal usage from your app code. You import it like any other module and call its methods. The magic is that this module doesn't actually initialize on the native side until that very first set item call fires. That's lazy loading happening automatically with zero extra code from you. Clean API on the JS side, fully typed and fully lazy underneath. Okay, let's talk numbers because this is where it gets real. Meta's own internal testing showed up to a 30% improvement in app startup time after migrating to turbo modules, along with over 20% lower memory usage compared to the legacy native module system. On the call latency side, this is the big one for anything performance sensitive. The old bridge was serializing every call at 5 to 10 milliseconds of overhead. JSI-based direct calls run in sub-millisecond time. That's not a small optimization, that's an order of magnitude. And for apps that register 20 or more native modules, published benchmarks show startup time dropping 25 to 40% purely from lazy loading. Now, important caveat. These gains scale with how many native modules you use and how often you call them. A simple CRUD app with barely any native dependencies won't feel this as dramatically, but for anything media heavy, animation heavy, or native call heavy, this is a massive win. So let's recap the whole journey. The old bridge serialized everything to JSON and loaded every native module eagerly at startup. That was the bottleneck. JSI replaced that with direct C++ references between JavaScript and native code. No serialization required. Turbo modules built on top of JSI to give you lazy loaded, fully type safe native modules generated automatically through Codegen. And the payoff is real. Faster startup, lower memory, and native calls that used to take milliseconds now happen in a fraction of that time. If you're still on the old architecture, this is genuinely one of the highest leverage upgrades you can make to a React Native app. Thanks for watching. If this helped, drop a follow and I'll see you in the next one.